Okay, so let's have a look at our next video, and this is around probability distribution. We'll have a look at the definition and then we'll look at an example using probability distribution. All right, so what is probability distribution? Well, it's a measure and we can use functions to describe it. But at the moment, it's just a measure of the probabilities of different outcomes occurring within an experiment or an event. So here's our first example. You can have a look at the screen. This is an experiment of where we tossed a coin 3 times. And as you can see, here are the outcomes all below. Okay, so if you toss a coin 3 times, you could get a heads, 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 tails, heads, tails, heads, tails, heads, 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 tails, 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 heads, tails, 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 heads, and tails, tails, tails. They are the outcomes of this particular experiment. Next, we have what we call the number of heads. Now, we can measure the number of heads, or we could measure the number of tails, right? This variable, right, the number of heads, we call x. And you can see that with the laser, because the number of heads that can occur during these experiments can change, because look, heads, heads, heads would mean that we have 3 heads. Heads, heads, tails, we'll have a look. There's 2 heads here, so that means our variable is 2. Because this changes, it's a variable, right? We call it x. And now what type of variable was this? Would this be a discrete random variable, or would this be a continuous random variable? Have a think. Well, let's have a think back to our definitions of discrete and continuous. Continuous being something that you measure, and discrete being something that you count, right? So if we were to count the number of heads, right, this would be discrete. So this is a discrete random variable. Okay, so now we also have the probability of each of these particular outcomes, right? And together, right, together with the probability associated with each value, okay, that's what we call the probability distribution. The probability of each event happening. Okay? And we can summarize this a little bit more clearly with a table. Okay? We call it a probability distribution. So I want to make a little table here. I guess I can just keep the background. Yes. And little x, the one that looks like an algebraic letter, x, just notes the number or the range of options, or the range of solutions, or the range of opportunities that this particular event can result in. So 0 represents that in 3 tosses of a coin, it's possible, right? It's possible to have no heads, because look, you could have tails, 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 right? It's possible that you could land on 1 head, or 2 heads, or 3 heads. Is it possible to land on 4 heads if you toss a coin 3 times? No. So this is definitely discrete data here, discrete variable. Okay. And what we're going to do now is list the probability of each of these events happening. And if we were to do this, if we were to take our time and measure, it's 1 in 8. Okay. That's for 0. What about for 1 head? Well, you could get a heads, tails, tails, a tails, heads, tails, and a tails, tails, heads. How many of them exist that you could get one head? Well, there are 1, 2, 3 of them. So 1/8 plus another eighth plus another eighth is 3/8. Same with getting 2 heads. It's 3/8. And what about getting 3 heads? There's only one way you can get 3 heads, and so it's just 1/8. And we just use some notation here. It's the probability that our variable x, which is, I'll write it here, the number of heads. This is the one that we decided. We could have gone with number of tails, but we just decided to go with number of heads. It wouldn't have made a difference. But it's the probability that the number of heads is equal to, or is this number of times. I'll say that again, I'll repeat it. We're measuring the probability of each particular amount of heads occurring. That's what this is. It's the probability of the number of heads occurring a number of times, where x is either 0, 1, 2, or 3, and the solutions are here. Just a couple of rules before we finish off, just something to note. Each probability, each of these, must lie between 0 and 1. I'll write that using this notation. Oh, lowercase. So each probability must be between 0 and 1. And then the sum of all these probabilities must be 1. So essentially, if I add 1/8 to 3/8 to 3/8 to 1/8, I will get 8/8, which is just 1 whole. That's the rule with probability distribution. Our next video, we'll be looking at an example trying to answer some questions.